So guys, you can see that it's 21 degrees centigrade. Now I place a finger on the LM35. See, it's increasing. Once it goes above 24 degrees centigrade, the LED turns on. See that? Now, once I remove the finger, the temperature will start falling. And once it goes below the 24, the LED turns off. See? Now I again place the finger. Again the LED turns on. Now again, when it will go below 24, the LED will turn off. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface an LM35 temperature sensor with a PIC16F877A microcontroller, and then we are going to display the output in Celsius form on 4-digit 7-segment cathode type display. Then we are also going to use a LED, and then we will set our desired temperature. Whenever the value goes above that desired temperature, LED will turn on as an alarm. And then when the values go below that desired temperature, then the LED will turn off. So let's get started. So guys, this is the 4-digit 7-segment cathode type display we are going to use. As you can see, it has 6 pins at the bottom at this side. On the other side as well, it also has 6 more pins. So it has total of 12 pins. So from the top, it looks like this. Now at the top back side, the leftmost pin is the D1. This is the digit 1 pin. Then we have A, F, digit 3, digit 2 and segment B pin. Then at the bottom left we have E, D, dot, C, G and digit 4 pin. Now guys, here you can see that digit 1 pin corresponds to this segment. Since it's a cathode type, so in this, whenever this digit 1 pin will be connected to the ground or a 0 from the microcontroller is sent to this pin, then this digit will get enabled. Now this is the D2, this is D3 and this is the digit 4. Now guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is our 7-segment display. I am again going to label it. Now at the top back side, top back left side, this is the digit 1 pin. This is the A, F, digit 2, digit 3 and B pin. Now at the bottom left, you have a E pin, D pin, dot pin, C pin, G and then the digit 4 pin at the bottom right like this. Now guys, this one is the digit 1 corresponding to this pin. This is the digit 2 corresponding to this pin, digit 3 corresponding to digit 3 pin, digit 4 being enabled by if you connect this pin to the ground. Now guys, let's connect it with the PIC. So you are going to need the 8 220 ohm resistor. You can use 100 to 300 ohm. It's like a normal resistor you use with an LED. It is basically a safety resistor. Now for each, there are total 8 while we have 12 pins on this segment, this module. Rest of the 4 pins, digit 1, 2, 3, 4, you do not need a resistor for them. So right now, let me show you how to connect the segments with the PIC. So A pin will go to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, you can use any available digital input output pin. I am going to use a port B pin 0 like this. I am going to use a port B for the 7th segment. You can use any port, but the port must have at least 8 LEDs. 8 pins. Now for the B pin, I connected to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B1. Then for the C pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B2. Now for the pin number D, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to send to the pin number B3 like this. Now for the E pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I am going to send it to the pin number B4 like this. Now for the F pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I will connect it to the pin number B5. Now for the G pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I will connect to the pin number B6 like this. Now for the dot pin, I will connect it to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, I will connect it to the pin number B7 like this. Now guys, remember this, you can use the other port as well, like port D has 8 pins, port C has 8 pins, or if you use any other PIC microcontroller, remember that the port must have 8 pins and 0 correspond to A, 1 correspond to B, 2 correspond to C, 3 correspond to D. This is important only because in MikroC for PIC, we have a built-in tool called 7-segment editor. If you don't follow this 0 for A, 1 for B, 2 for C, and so on, etc., this scheme, then you will not be able to use that tool. Then you have to set the digits manually. So to use that tool, you have to follow the scheme. Now guys, our segments are connected. Now let's connect the digit pins. For the digit pins, you can use any available digital input output pin. I will use the port D for the digits. For the digit 1, I will connect to the pin number D0 of port D. For digit 2, I will connect to the D1 pin of the port D, that is pin number 20 of the PIC16F877A. For the digit 3 of the 7th segment, I will connect it to the pin number D2, that is pin number 21 of the PIC. For the digit 4, I am going to connect it to the pin number D3, that is pin number 22 of the PIC16F877A, like this. In this way, this module is completely connected to the PIC. Now guys, this is our LM35 DG sensor, easily available in the market, and one of the most used temperature sensor in the world. So in my view, it is one of the most used. There might be others which are used better. So guys, it has 3 pins. If you hold it like this, and then you have an LED. Here we will use this LED. This will be, as told you earlier, this will be used for the purpose of demonstrating whenever the temperature goes above a desired value. We will program it as well. Now for the pin configuration, LM35 has 3 pins. One on the left is the VCC, the center one is the ATC, the right one is a ground pin, like this. Now guys, for the LED we have 2 pins, one shorter and one longer. This is ground and this is 5 volt. Now guys, for the LM35, you connect the VCC pin directly with the VCC pin of the PIC. Then for the ADC pin, you can use any available analog to digital converter pin of your PIC. I'm going to use a A0. AN0 is available in my project. Now guys, for the ground pin, connected directly to the ground. It is simple as that to connect the LM35 DG with a PIC. Now guys, for the LED, connect the ground pin directly with the ground of the PIC, like this. For the 5 volt, you will need a 220 ohm resistor, or you can use 100 ohm, 330 ohm, but less than 500. The higher the value of the resistor, the dimmer the LED will go. So 220 is ideal. You will connect 5 volt pin to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, you can use any available digital input output pin. I am going to use a pin number C0, that is pin number 15 of the PIC16F877A. In this way, our complete circuit is completed. Now guys, take a look at this 7 segment module. Digit 4 is where I will display C constantly. It means it's in Celsius. The temperature displayed will be in Celsius. For the digit 3, this will be our unit digit. Digit 2 is the 10th and digit 1 is the 100 digit. The maximum temperature that LM35 can go is like 130 to 140 degrees centigrade. So it cannot go above the 100 digit. So this C means centigrade, unit 10th and 103 digits will be there, like this. Like it is showing 28 degrees centigrade. So it can display 128 as well, but in my scenario, it will not be able to reach that temperature. So let me introduce you to the hardware. Okay, this is the hardware here, guys. As you can see that this is LM 7 segment cathode, 4 digit cathode. I had just installed this screen, so because it shines a lot, so in the camera you cannot see the display. So I just use this translucent plastic case to cover it up. So when it will shine, you will be able to see through the camera. You can see it using the naked eye, but with the camera it makes a bit of problem that it shines and camera cannot focus. And this is the LED we are going to use connected to C0, and this is our LM35 sensor over here. So this is our hardware. This is our PIC16F877A in the back. That is the PIC 3.5. So this is our simple hardware. Now guys, let's get to the programming. So let me zoom it in for you. Let's get to the hardware page. So this is the version 7.2.0 of MikroC for PIC. 7.5.0 is also available. You can upgrade to that, or if any other version is available. So click on new project wizard pops up. Click on next, write the name of the project. What is the name of the project? I write LM35 7 segment LED tutorial learning microcontrollers. Now guys, this is the place where I will store the code. PIC16F877A is the one I am using, and 20 MHz is the crystal I am going to use. So click on next and finish. Now first of all guys, before doing anything else, press Ctrl S to save your work, like this. Now the next thing is, you go to the void main. First of all, initialize the port on which your 7 segment is connected, that is tris B equals to 0 cross 0 0. It means, like in case of Arduino, it's pin mode. Here it is a tris B command. All the pins of the port B are now an output pin. 0 means output, 1 means input. Now, like in case of Arduino, you give the initial state by using digital write. Here we will use the port B equal to 0 cross 0 0. This means the port B is declared as output port, and here it means that port B is now initially at 0, that all the LEDs at port B must be at 0. So we give some initialization delay. This delay is not compulsory, but I prefer you give it in the one time loop. So this is it. Now this is how our 7 segment is initialized, but for the 7 segment we have characters. So for that we will need a array, like integer array. So we initialize an integer array like this. Display maximum digits can have a 0 to 9, and with digits from 0 to 9 you can make any character in the world, any digit in the world. So it starts here. So first of all, now go to the tools. Here you have this 7 segment editor. Click on it. This pops up. On it you make a 0 like this. Now for the 0, zoom in. It says that common cathode in decimal it will be 63. You copy it, paste it here. Now this means that display and array sample 0 means a 0. So display 0 means a 0 on the 7 segment like this. Now for the 1, go back, zoom out, make a 1 here. Now this is the 1, and let me zoom in. What it says? It says it's a 6. So for 1 it's 6. Now display 1 will display a 1. Now that's why I was telling you that this scheme of 0 to A, 1 to B, 2 to C, 3 to D must be maintained. So you can use this tool. If you don't maintain that scheme, then you will not be able to use this tool. Then you have to manually give the commands. So now make a 2. Now let's make a 2 like this. Now this is our 2. It's 91 for the common cathode, and we are using a cathode. Now make a 3. And to make a 3, it's simple as that. Now 3 is 79. Now let's make a 4. 4 is simple as that. Now this is a 4, 102. Now make a 5. Now this is our 5, 109. Now make a 6. 125. Make a 7. 39. This is the 39 for the common cathode. Now make a 8. All the LEDs will be on for the 8. Now for the 8 we have 127. Now make a 9, the final digit. Only one LED must turn off like this. Now this is our 9. It's 111. So paste it here like this. Now close your array. So you can see that at display 0 it's a 0 on the 7th segment. Then we have 1, 2, 3, 4 up to 9. Now by using 0 to 9 digits with unit 10 and 100 digit, we can make any digit possible till the 100 digit. Now this is our tris B segments. Now remember that we had also connected digit pins to the port D. Now we initialize them. Write down tris D equals to 0 cross 0 0. I had declared the whole port D as output because I am not using any other pin of the port D, while the digit pins are only at first 4 digit D0, D1, D2 and D3 are being used. So here it's good. If you have any other thing at D7 or D6, then you will initialize them separately. Now for the port, I use port D, that is the initial state of the port D must be 0B. I will send binaries 1, 2, 3, 4, 5, 6, 7, 8. Now see that there are a total of 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now this is important. See that I am sending 80. This means that to the right is the D0. This is the pin number D0. This represents the pin number D1. This is for the D2 and this is for the D7. So from right to left, it's D0 to D7 in binary. Now we have our digit pins at first 4 digits D0 to D3, 1, 2, 3, 4. Now why 1? Initially, any pin in the cathode formation must be at 1 because if we send a 0, it becomes enabled. So I write because 1 means in case of cathode that digit is disabled. So now this is important. So as I told you in the slide that in case of a cathode, 1 means that the digit is disabled, and if we send a 0, it means the digit has been enabled. So initially only the digit pins D0 to D3 are disabled. So we will enable them when we are going to send that digit one by one. This is called multiplexing technique. So give some initialization delay. Now our 7th segment is initialized completely. LEDs plus digits. Now we have a LM35 sensor, and for that we will need the ADC library. Go to the right, MikroC library, expand them. Now this is ADC, check mark this. Now you write the command ADC init. Now give some initialization delay like this. Now guys, this command initialize all the ADC pins of your PIC microcontroller. So all the ADC pins have been initialized now. Now what we need is that LED pin. Our LED is at port C.F0. So we write trace C.F0 equals to 0. LED pin declared as output. Like in case of an Arduino, it is pin mode C0 output. Now the initial state of the LED must be off. Port C.F0 equals to 0 initially, and we give some initialization delay for the LED as well. Now we have our 7 segment initialized, then we have our ADC pin initialized for the LM35, then we have the LED initialized. So now we can go to the forever loop. Now for the forever loop, write down while 1 starting here and ending here like this. Now guys, first of all, what we do is that we have to take the value from the sensor, whatever the value is. We take a raw value. For that we initialize the integer like temp. So we write temp is equal to ADC underscore read read 0. Now this is the syntax of the command for reading the data from the sensor using the ADC library. This is our variable which will store the data. This is the command, and this inside it is the channel. So the channel from which I am taking the command is 0, AN0, pin number 2. If I am using pin number 3, that is AN1, I will write 1, that's all. If you are using any other pin other than AN0, then check the datasheet, whichever AN pin it is, then that is the digit you will write here. Now give some initialization delay. This is not compulsory to give delay here, but I give just because it's good to give. Now guys, the next thing is we have our temperature pins initialized. Now we have to go for the next step, that is to display this value on the screen before we convert it to Celsius. So to display it on the screen, first of all we will need the initial state of the port D. First of all, we enable the digit on which the data is to be displayed. Remember that digit 3 is this is the digit 3 at pin number D2 is our unit digit. So I make it 0. Now it's enabled. Now what I have to display here is that port B equals to display whatever that variable is, this dis display. Inside it I will write this variable temperature percentage of 10. Now why the percentage of 10? Now this is very important. Now see that I go here, see that when I will write a digit here, it is like 0 to 9 maximum on this. Then the control has to be transferred to the 10th digit from unit to 10th. Now this basically percentage symbol is a remainder symbol. It will take the remainder and it will transfer rest of the value to the next digit. So this is important to transfer the control to the next digit. If you don't use this mode symbol or remainder symbol here, then the control will not be transferred. So you have to use it. So this is our unit digit to be displayed at this point, that is the digit 3 pin, digit 3, and then after displaying the digit, after some delay, you have to give some delay here. and this delay is important to control the blinking. I give like delay of 25, and if it is high then we will change it to see which suits our requirement, that there must not be any blinking. And in multiplexing technique, you basically blink one by one. You send a digit to the each pin, and at such a speed that your eye gets torched. That is, seems like it's constantly on while it is blinking one by one. It is updating one by one. Now, after displaying the digit, we have to disable the pin. For that, just copy it, bring it to the initial state like this. Now, this is for the unit digit. Now, do it for the 10th digit. For the 10th digit, we have to like enable a 10th bit. For that, this is our 10th bit, it's enabled, and disable the unit bit like this, and now add here divided by 10, temp divided by 10, just starting bracket and ending bracket. Now the 10th digit will be displayed here, and now again go back to the initial state. Now do it for the 100th digit. For the 100th digit, do the same like this. Now disable the 10th digit, enable the 100th digit, and now make it 100. Temp divided by 100, that's all. Now for the centigrade, you copy this and place it here. And what you should write, make a C first of all. Now you go back to the 7 segment editor tool here. This is the tool here where it is 7 segment editor. This is the tool. Now what I should do, I should make a C here. Let me zoom out. It don't work when you are zoomed in. So this is a C. So C looks like this. For the cathode, it has 57 value. Just copy it. That's all we need. Now enable that digit, that is the 4th digit, and disable the all the other digits. And inside the bracket, you just write C because it's a constant 57. It will display 57 at this point. Now at this time, the temperature is not converted into Celsius. So we convert it into Celsius by using the standard LM35 formula. That is temp is equal to ADC. So the value is red, temp, whatever the value is coming from the sensor, you have to multiply it by the voltage applied. We are using 5 volt here. So in case you are using 3.3 other voltage, then you have to write that voltage. This is the V reference divided by 10. Now this is the standard formula for LM35 to convert the value to the Celsius. If your sensor do not convert value using this formula, it means your sensor is not original. So you have to check what is the problem with the sensor. Okay, like this. Now we build it. It built successfully, and we burn it to the microcontroller. So open this PIC16 programmer tool, go to the import hex file. On the top we have this file, click on write. Okay, the new code is being written. Let's zoom out and get to the hardware. So this is the hardware. Okay, now I will power it up from this PIC 3.5. Now you can see that it is showing the data. It is showing the data, but the blinking speed is very slow, that we cannot see it smoothly. So what we do is that we go back. Now we go back. Now what we do is that is what I was telling you. These delays are very important. You reduce the delays. You make them 1 and you make it just 2. Remove the 5. The lower the delay, the more smoother will be the value on the display. Like this. Now this is fine. The smaller the delay, the more smoother will be the value. Now we had just removed the delay with a huge difference. I build the code and I burn it again. Okay, it's built without any error. So let's get to the hardware again. I build the new code. I click on write. Okay, the new code is being written. Just wait. Okay, now see it's smooth. way smoother than previously. Let me show you from the near. See that it is showing something 20 to 21. It is clear from the naked eye, but on the display you know that there is some problem with the camera. See, it can show like 20 to 21, and then we have this C in the end like this. So guys, it is showing like 21. This is 0, the 100 digit, unit digit, 10 digit, and the 100 degree, like 21. I place the finger on the LM35 sensor to increase the temperature. See, it is going up. 22, 23, 24. See, the temperature from my finger is being transferred to the LM35. See, 25, 26. Now you remove the finger, it will go down. See, it is again falling like 24, 23, 22. See, it has fallen. Now what I do is that, let me zoom in. I have to add the LED. I make it like right now the temperature is at 22. So if it is at 22, this means that if it goes above like 24, then the LED will turn on. So we had taken our threshold. Now we add this as well. So let me zoom in. So I add here that if temp is greater than 24, then LED, where is the LED? LED as port C.F0, copy it, will turn to 1 like this, and then else it will remain off. So write the else condition, else it's off like this. Now build this code. Let's see the LED works or not. Okay, let's build this code as well. It's built. Let's burn it. Let me zoom out and go to the hardware so we can burn the code. Okay, I will click on write. The code is already selected. Okay, the new code is being burned. Let's see what happens. Now see that it says 21. Now I think I can make it even better. Okay, it's fine. You can see that. You can see it like it's 21. It's somewhat viewable. So I place the finger on the LM35. The temperature will increase. 23, 24, 25. See the LED turned on after it increased from 24. See that it's now reached 26 degrees centigrade. I remove the finger, it will fall and the LED will turn off. See, the LED turned off once it went below 24. See, 23, 22, it is falling now. So guys, that's how you can make this work. So this is our, I again place the finger, see, it is 23, 24, 25, the LED turns on. 26 and onward, it will remain off. I remove the finger. Now the temperature will fall again and the LED will turn off. So guys, I hope you learned from something from this video. Thank you very much for your time. I will share the code of this video, all the MikroC for PIC files as well. In the description, you will have a Google Drive link. You can use that to download the MikroC file and then you can play with the code. So you can make different digits using that segment tool. And if you have any questions or queries, you can ask in the comments. So thank you very much for your time, guys, and have a nice day. Guys, there is a bit of mistake. I sent like you can see that at port B I used 57 inside it. Like I wrote it like this 57. It was a mistake, so you make a correction. So it will not be like this, it will be like this, just 57. So because we are sending an integer to display the centigrade on the screen, So this will be an updated code in the Google Drive. So I show you how this works. I click on write. Okay, the new code is being written. Let's get to the hardware. Okay, see, it's now working fine. It's now C, a correct C. You can see that. So guys, thank you very much. And if you have any questions or queries, please do ask in the comment.